All right, so here's lesson 6.5 on properties of logarithms, and it begins just asking us a few questions that's coming straight from our notes or what we talk about in class. Says complete the sentence below. We have log base a of 1 equals, and remember, whenever your argument is 1, the log question is saying your base raised to what power equals 1, and that's straight from our exponent rules. Anything raised to the 0 power equals 1. So log base anything of 1 is always going to be equal to 0. Now it says log base a of a raised to the r. Remember, whenever your base and your argument are the same thing, they basically undo each other. Your base and argument are the same thing. You can undo those, and in this case, we would just be left with the exponent that remains. So that is going to leave us with r as our answer. This is the same base argument rule being used here. Those two cancel out. We're just left with the exponent. All right, so now this is just a product rule, which states that if you have a product as a part of your argument, you can separate it using addition. So we'll have log base am plus log base a of n for our answer. Notice that they have this distractor here, this m plus n. Remember, when you use the product rule to separate into addition for logarithms, you are going to keep the log and the base as a part of your expression. All right, so now it's asking us about the quotient rule this time. And remember, whenever you have a quotient, your fraction here inside the log expression, you can change it to subtraction. You are going to have log with the same base of your numerator minus log with the same base of your denominator. So remember, it's numerator minus denominator and not the other way around. For number 5, this time, so now you don't have the same base argument situation, but your argument does have an exponent. Remember, as we talked about now, for this rule, our exponent is going to become our coefficient of the expression. So whenever you have an argument that is raised to a power, you can take that exponent and change it to the coefficient of the entire logarithmic expression. So we will move that r down front, and that will be our answer. So now it's saying use the properties of logarithms to find the exact value. This is going straight back to that same base argument rule. Remember, the natural log has the base of e, and so we have a base e and e as a part of our argument. They will undo each other. So ln e undoes each other, and we will have 2 as our leftover, which is our answer. So now we're using the properties of logarithms. So first, we see that we have addition between logs of the same basis. So we're going to use the product rule to combine this into one log expression. It will be log base 42 of 6 times 7. And 6 times 7 simplifies to being 42. So we would end up with log base 42 of 42. So we have the same base argument situation going on. That simplifies and reduces to 1. So again, you use the product rule, you multiply the 6 and the 7, and then you have 42. You have the same base in argument, log base 42 of 42, and we reduce that, and that would just be 1. Now we have a quotient rule situation because we have subtraction between logs of the same basis. So we are going to have log base 4 of 24 divided by 6. 24 divided by 6 is 4. So that will leave us with just 1 because we'll have log base 4 of 4, same base as argument. That equals 1. All right, so for starting with number 9, they're asking us to write the log expressions as a sum or difference of logarithms, and it tells us to express the powers as factors. So basically what we're trying to do is break apart the condensed logarithmic expression as much as we can. So we start out with a quotient being a part of our argument. So we're going to use the quotient rule to change it from division to subtraction. So we'll have log base 4 of x to the 3rd power, which is our numerator, minus log base 4 of y to the 8th power. So now we're not quite done yet. We see we have exponents on our arguments, so we want to use the power rule, which says we can make those exponents become the coefficients of our log expression. So we'll find our final answer will be 3 log base 4 of x minus 8 log base 4 of y. Number 10, it says we have log base 6 of x minus 4 over x squared. Again, we'll use the quotient rule to change the division to subtraction. And then from there, we can use the power rule here on this expression on the right. So we'll take this exponent, we'll make it our coefficient, and this will become log base 6 of x minus 4 minus 2 log base 6 of x. For number 11, we have a similar situation. This time we have log base w of 7x over 2. Again, we want to start out with the quotient rule. We'll change the division to subtractions between logarithmic expressions. So we'll have log w of 7x minus log base w of 2. Now we can use the product rule because we have this 7x over here, which is multiplication. So we'll separate the 7 and the x using addition. So we'll have log base w of 7 plus log base w of x minus log base w of 2. For number 12, we have a same base argument situation. We can start out though with the power rule. So we'll take this 83, we'll move it down to the front. So we'll have 83 times log base 8 of 8. And the same base argument situation, remember that just reduces to being 1. 8 raised to the first power is 8, so that's why it reduces that way. So we're just left with 83 times 1, which is simply 83. Number 13, another same base argument situation, almost identical to number 12. It's just using the natural log. You bring the 9 down in front using the power rule. You make that exponent the coefficient. Then you have log base e of e. So those will reduce to being 1. You have 9 times 1. The final answer is just 9. Number 14, you have log base 14 of 7 plus log base 14 of 2. This time we are trying to find the exact value of the expression using the properties of logarithms. So in this case, we want to take the expanded expression and we want to condense it this time using the logarithm rules. So here we have addition of logarithms of the same base. So we can use the product rule to combine them. So we'll do 7 times 2. We'll multiply these arguments. So we'll have log base 14 of 14. Now we have the same base argument situation once again. That reduces to being simply 1. For number 15, this time we have log base 6 of 42 minus log base 6 of 7. So we want to use the quotient rule because we have subtraction between logarithms of the same base. So this time we'll divide the arguments. We'll take the 42 and divide it by 7. So we'll have log base 6 of 42 over 7. We can simplify that. We'll have log base 6 of 6. Now we have the same base argument situation again. That simply equals 1. Number 16, we have 2, and this is all raised to this power. So everything up here that you see, this is all part of the exponential expression. So when we're looking at it now, we want to begin to work on this exponential expression up here. So we have log base 2 of 1, which we can reduce. When the argument is 1, that means that the whole thing is 0. So we have 0 minus log base 2 of 7. So that's simply going to be negative log base 2 of 7. Okay, so now we can use the power rule. We have a coefficient of negative 1 here in front of this log expression. So we'll make this negative 1 become our exponent. So now we have a negative exponent rule, a situation. We can apply that negative exponent rule. That simply means that you change its position in the fraction. So we move this 7 to the denominator. So it will be 1 over 7 raised to the first power. Now we will use the property of inverses. Remember, logarithms and exponents are inverses. So when we have a base raised to the log of that same base, they will undo each other. So this 2 raised to log base 2 undoes each other, so we're simply left with 1 over 7. So that is our answer, 1/7. Number 17. So this time we have log base 3 of 27x. So we can expand first using the product rule. So we'll take the 27 and separate it from the x using addition. So we have log base 3 of 27 plus log base 3 of x. Now we see that we have this 27 over here on the left. So by now we can recognize that 27 can be written as a power of 3. So 3 raised to the third power equals 27. So we'll rewrite this 27 as 3 raised to the third power. So we have log base 3 of 3 raised to the third power. Again, we can use the power rule. We'll bring this exponent up here down to the front. So we'll have 3 times log base 3 of 3. Here we have same base argument situation. This cancels. So we're left with 3 times 1, which is simply 3, and our final answer now is 3 plus log base 3 of x. So everything that we were doing here was only simplifying the left part of this expression here, just this log base 3 of 3 raised to the third power. Geez, that's a lot of 3's. Number 18 says simplify the logarithmic expression. It says express powers as factors. So again, we want to break it down and expand it in this case as much as we can. So this is a simple one. We just want to use the power rule. To simplify it, we'll bring this 5 down in front. It'll be 5 log base 6 of z. Number 19 says write the following expression as a sum and or difference of logarithms. So we have ln of e times x. So we want to change that to addition because we see is multiplication going on in here first. In this case, now it may be tempting to just strike out the ln e, but this is not e raised to the x power. This is e times x. This is multiplication in here. So we need to separate it first using the product rule. So we change it to addition. So now we have ln of e plus ln of x. So the ln e can now reduce to be 1, and the ln of x simply comes down. Number 20, we have ln of x over e to the 4x. So now, first we want to use the quotient rule. We'll change this to subtraction. So we'll have ln of x minus ln of e raised to the 4x. Remember that we can use that power rule. We'll bring the 4x down. We'll have 4x times ln e, which reduces to 1. So we're simply left with 4x. So we have, for our final answer, ln x minus 4x. Number 21, we have log base d of u to the 7th times v to the 3rd. So we have multiplication going on in here. So first we'll change that to addition using the product rule. So we'll have log base d of u to the 7th plus log base d of v to the 3rd. Now we can use the power rule to move these exponents to being our coefficients. So we'll take the 7 down, we take the 3 down, and we end up with 7 log base d of u plus 3 log base d of v. For number 22, we have ln of x to the 9th power times, this is multiplication in between here, times the square root of 5 minus x. So first we want to take that multiplication and use the product rule to separate it into addition. So we have ln of x to the 9th power plus ln of the square root of 5 minus x. Remember now with the square root of 5 minus x, that's actually 5 minus x raised to the 1/2 power. So we'll take that 1/2 power and we'll bring it down in front of the logarithmic expression. Over here on the left, we just took the 9 and moved that down to being the coefficient here. So this is our final answer, 9 ln x plus 1/2 ln of 5 minus x.